We have three area between curves problem. They are all vertical rectangle and dx integral. So in this video, we will do trigonometric functions. So number one and number two, they are just like top curve minus the bottom curve, but number three is a pretty special case because there are two regions and the position of the top curve and the bottom curve changes. So let's start at number one. So number one, on the left hand side, we have y equals to secant square and y equals to 8 cosine x, and we have x between negative pi over 3 and positive pi over 3. That actually helps me a little bit. First of all, let me find the intersection. So first we set them equal. We have secant square x equals to 8 times cosine x. Secant is 1 over cosine. That is equals to 8 cosine. And then we multiply both sides by cosine. So on this side, we have cosine to the third power, right? And then in the meantime, we divide both sides by 8, all right? First, multiply both sides by cosine, and then you divide both sides by 8, and then we have that. And then we take the third power on each side. So we have the cube root of 1 over 8, right? So we have the cube root of 1 over 8 equals to cosine x, so that is one half, right? So cosine x is equals to 1/2. So the domain actually helps me a little bit. So if you look all the way up, the negative pi over 3, because we have cosine pi over 3 equals to 1/2, and cosine negative pi over 3 also equals to 1/2. So that tells me at these two intersections, we have cosine equals to negative pi over 3. No, sorry, not cosine. X equals to pi over 3 and x negative pi over 3 and positive pi over 3. So we know that the lower limit and upper limit goes from negative pi over 3 to positive pi over 3. And then which one is the top, which one is the bottom. So this is the area that you are looking for, right? And then within this region, you pick a point at any point. So let's say this point, and then this is your vertical line. And then to draw the rectangle, you do the midpoint rule method. So midpoint rule, we take that point as a midpoint, take this point as a midpoint, and then you sketch your rectangle. And then the top curve, so the top curve is yellow, the bottom curve is pink, right? So the top curve is y equals to secant square x, and then did I label that right? Let's see. Okay, secant square and cosine. Maybe I labeled the graph wrong. Maybe, not maybe. This one I labeled the graph wrong. So this is supposed to be cosine. So let's fix that right now using a different color. So this, the parabola that is facing down, so that is supposed to be 8 cosine x. So this one, let me change this color too. So we have 8 cosine x, and then the other one, the one on top, let's use another color to rename that. And then you see another parabola that is kind of like facing up. That one is actually a secant square, because secant square, right? Secant square, you cannot have an upside down graph. So this is a secant square x, and then I have to change that to a secant square x. So this one is a secant square x, because the reason I realized that is secant square x, right? So you square the secant, that means there is no curve below the x-axis. So that's why that is a secant square x. So the top curve is y equals to secant square x. So let me follow my color code. So the top curve is, wait, hold on. The top curve is 8 cosine x. So the top curve is y equals to 8 cosine x. And then we have the bottom curve, that is y equals to, should I just completely follow the color code? So the bottom curve, bottom is y equals to secant square x. And then I can do integral, that's for the next problem, and then I can do integral, x goes from negative pi over 3 to past the pi over 3, and then you do 8 cosine x minus secant square x dx. So this is the integral that finds the area between those two curves, right? So we will just do setup but do not evaluate in here. All right, so that's the first one, and then the next one we have a cosine and a 4x squared. All right, so this first we have a cosine, so this time let me double check cosine pi x, got the graph right, and then the 4x squared minus 1 parabola facing up, shift 1 unit down, so the graph is perfect. So first of all, we have to figure out the intersection. So the intersection, we have two intersections, one right here and then one right there. But if you set them equal, you have 4x squared minus 1, then you will have 4x squared. Should I use this color? 4x squared minus 1 equals to cosine pi x. I don't recommend you to go this way because this is hard to solve. Okay, let's try something else. Okay, I know that both intersections, they are on the x-axis, so that means I can try 4x squared minus 1 equals to 0. Then we have x squared equals to 1 over 4. Then x is equals to plus or minus 1 half, right? Okay, one more thing. Cosine negative 1 half pi, so that will be pi over 2, and then cosine past the pi over 2, so cosine negative and past the pi over 2, so that will be 90 degree clockwise and counterclockwise. Just think about the unit circle. So at that point, the point is on the y-axis, that means x is equals to 0, x is equals to 0. Sorry, yes, that means x is equals to 0. Cosine refers to x, so we know that at positive 1 half and negative 1 half, they intersect each other. So negative 1 half and positive 1 half. So this will be my area then. So I know that this is from negative 1 half to positive 1 half. They are both x equal. Okay, got it. And then what about the top curve and the bottom curve? So let's take a point. So this is point. This is a point. Maybe we should take a point off the y-axis so that I won't overwrite the y-axis. So here, which is the top, which is the bottom. So the top curve is y equals to cosine pi x, and then the bottom, that is y equals to 4x squared minus 1, right? So if you draw the rectangle, you go like that using the midpoint rule. We take that point right in the middle of the width. Then we have area that is equals to x equals to negative 1 half to x equals to positive 1 half, and then we have top minus bottom, that is cosine pi over x, and then we subtract the entire bottom curve, that is 4x squared minus 1. You have to use this parenthesis. This parenthesis, the one that wrapped the 4x squared minus 1, is not optional because there is a minus. You have to distribute that to the 1 as well. So after you distribute the minus sign, you have minus 4x squared and then plus 1. So this I will just do setup but do not evaluate. This one you can easily evaluate the integral. So number 2 is done. Let's talk about number 3. Switch color for number 3. So number 3, this is a very interesting problem to discuss because there are two areas, right? So do you see that this is, let's say we call this A, and then just use the same color. We call this B. So do you see that in region A, the y curve is above the green curve, and then in region B, the green curve is above the y curve. All right. So that's what makes this problem so interesting. So first of all, let's find the intersection. There should be 3. The intersection that takes quite some work. So first we have tangent x equals to, I'll just do this, 2 sine x equals to tangent x, do you still remember how to solve a trigonometric equation? That's why I picked this problem. So we have 2 sine x that is equal to sine over cosine. And then we multiply the cosine to the other side. So 2 sine times cosine. That is equals to sine x. And then we subtract sine x. So 2 sine x cosine x minus sine x equals to 0. And then let's bring this to this side, and then we factor out the sine x. And then we have 2 cosine minus 1 equals to 0. And then using the zero product property, 2 cosine x minus 1 equals to 0. So sine x equals to 0. We have x equals to 0 then. And then this one is cosine x equals to 1/2. And then we have x equals to negative pi over 3. And pass the pi over 3. So this one I know that this is a 0. This is a pi over 3. And then that corresponds to negative pi over 3. All right, just got the 3 intersections. So we have 2 regions. So let's deal with them separately. Let's deal with region A first. So region A is from where to where? From x equals to 0 to x equals to pi over 3. Okay, and then the top curve, with a little bit of practice, you don't even need to sketch your rectangle, right? So the top curve is y equals to 2 sine x, and then the bottom is y equals to tangent x. Okay, and then that is x equals to 0 to pi over 3. Then you use the top minus the bottom. Okay, so that is region A. And then region B. So region B is from x equals to negative pi over 3 to 0. And then the top and bottom, the top is the tangent, the bottom is the 2 sine. So the top is the tangent x. And then bottom is y equals to 2 sine x. Right? Don't jump straight to the integral. Put this down, set up the integral, and then you evaluate, right? And then the integral is from negative pi over 3 to 0, and then you take the top minus the bottom. So that is for region B, and then we have one for region A, right? So this is for region A, and then this is for region B. This is only you are trying to show your work, but when you put a final answer, you have to add them. So the final answer, let's say I'm doing homework online, you have to add these two together. So you have to do something like that. So you have to do a pi over 3 to 0, 2 sine x minus tangent x dx, and then you plus from negative pi over 3, 0, tangent x minus 2 sine x dx. All right, so that is the answer. So this is the final answer. But the final answer, you have to evaluate this and then integrate and then plug in using the fundamental theorem of calculus, and then you give me one answer, right? Okay, the reason I picked this problem is because there is another way to write this integral. So let me take this graph with me. All right, so let me just take this graph with me. So I'm going to take this graph, copy, and then paste over here. So that is running out of space. Okay, let me just put it right here and then make the graph extremely small, because that is enough space for me to explain the work. Okay, you know what? Let's make the graph bigger. Okay. All right, erase this extra line. So this one, do you see that this is origin symmetry? Origin symmetry, what does that mean? That means the area of A is equals to the area of B. Do you agree with that? The area of A. So what that means is, this is what we can do. So let me show you. Another way to do this is you can do this. You have the integral from 0 to pi over 3. All right. And then you have 2 times sine x minus tangent x dx. So this is only for area A, right? But you know that B and A, they are equal. So all you have to do is you just multiply by 2. That's it. Then you don't have to set up the other integral. But you know what? I don't really recommend this method because the purpose of giving you this problem is to practice the two regions, right? So from one region to another, you know the top and bottom, the top curve and the bottom curve, they have to swap. Then you have to set up two different integrals. I prefer to go by the region A and the region B method. Okay, so that is the end of this video. In the next video, I will do more examples. So I will see you all in the next one. If you think my instruction is helpful, let me know in the comment below. Like the video, subscribe to my channel, share the video for me. Appreciate your help. As always, see you all in the next one. Signing out for now.